So we're going to be talking about the mathematical modeling of what Mike and Sabrina have discussed with you in relationship to the RRV in terms of the science of its motion and the motion storyboard. So what exactly is mathematical modeling? Well, it's the method of simulating real-life situations using mathematical equations to predict future behavior. And so this is usually done through direct or indirect measurements, and these measurements become the data or variables. And we can use graphical representations of the measurements to predict future behavior, or we can look at the relationships in respect to equations and inequalities to also predict that future behavior. So let's look at the real-life situation you've been studying in respect to forces. So often people define forces as a push or pull resulting from the interaction of two objects. So as an example, if we lift a bucket, right, that's a pull. If there's a sailboat, the air pushing on the sail is a push. If we look at the moon and the earth, right, these are two objects that do not directly touch each other, but there's an interaction of the force of gravitation between the two of them. And so, how can we describe these forces? Well, these forces are usually described in the form of its size as a magnitude and using a direction, which is usually shown as an arrow. And so we can call these force arrows are actually called vectors. And that's what we can use to describe these forces. And using our coffee filter example, if you remember previously, when we dropped it and it fell to the ground, then there was a force due to gravity that pulled the coffee filter down. But there is also a force due to air resistance, because when I hold this, right now the force of my hand keeps it from moving. But when I let it go, air resistance slows it from falling very fast, like the book fell in our previous example. So when looking at the net force, when we had 5 filters stacked one on top of each other, then the force of the air resistance was low in comparison to the force of gravity. So they tended to fall faster than when we had 5 coffee filters that were spread out, because the force to the air resistance was greater when the coffee filters are spread out. And so the net force here is much less pulling down than the net force here. Hence, the coffee filters, when they're spread out, fell slower than the coffee filters that were stacked one on top of the other. And so, if we took a time of each time that a coffee filter fell, we could do trials and do another time and get another time. And each time, right, we could represent that set of times by looking at measures of center in terms of mean, median, or mode, measures of variability or spread by doing things like a 5-number summary, finding the range or the interquartile range or the mean deviation, or we can get a graphical representation of that variability with a histogram, a stem plot, or a dot plot. And so one of the ways we can represent the interaction between the forces and the motion is we can vary the number of coffee filters. And so in doing so, we would do the ratio of the surface area to the weight. So we can represent the interaction between the forces and the motion by showing a variance of the number of coffee filters. And we can ratio the surface to area to the weight as an independent variable. And as our dependent variable, we have the time. So that we have a graphical representation of how as the surface area to weight ratio varies, the amount of time varies, and how long it takes for the filter to fall. And then those points will be our scatter plot. So how does all this modeling relate back to mathematics Common Core Georgia Performance Standards? Well, if you look at the 6th grade, then understanding statistical variability and summarizing data distributions through what other than measures of center and variability is in the Common Core GPS for Georgia. In the 7th grade, you can look at informal inferences between the population of looking at, as an example, the coffee filters in a stack flowing and coffee filters spread out flowing. You could also, as an example of that, put on the ground a target square and look at uniform probability with respect to where it would land if you were dropping down from the center of the square. In addition to that, in the 8th grade is none other than investigating patterns of association and bivariate data between independent and dependent variables. So you see, using just this one real-life situation, you can target all levels of middle school mathematics in data and statistics. And so in summary, mathematical modeling is a way to apply problem-based inquiry learning so that you have methods of real-life situations and predict their future behavior. And by using measurements, and in our specific example, we use the measurement of time, we use the measurement of surface area, and weight to actually give us both graphical representations, they can give us algebraic representations to describe and predict real-life situations.